I've got an example that we're going to look at today. Talking about Andrew. Andrew, you're creating a rectangular dog run in your backyard. Did you know that today? Do you have a dog at home? Oh man, well this is perfect. You're going to build a dog run and you're going to get a dog that runs. What are we going to name your dog? Jack, what did you say?
Sophie.
Sophie? What is that, somebody's girlfriend's name? Whose girlfriend? Oh, that would be rude. If I got a dog, I would not name my dog after my girlfriend. That would be a quick way to lose said girlfriend. Let me go ahead and tell you guys that. Okay. Oh my goodness gracious. Don't you listen to Jack's bad advice there, Andrew. You name it something simple like, Gus or Piper or Laddie or something. All right. So first thing we want to do when we go through this word problem, I'm not going to read every word. I'm going to try and figure out what they're asking, like Reed had said at the beginning. So we want to find the range of options for the width. Okay, that's what we're looking for. Rectangular dog run. I might as well make a picture too, right? I'm a visual guy. So I'm going to make a rectangular dog run. And I'm going to say let W be that unknown width. That's step 2, isn't it? Assign a variable. Now, hopefully at this point, what I can do next is I can go through and write the length in terms of the width. Okay, notice that phrase that I'm using, in terms of. That means that whatever expression I use for the length, it needs to have what in it?
W.
Yeah, very good. It needs to have W in it. Okay, that's what we mean by that phrase, in terms of. So I'm going to highlight a section of this. Notice I haven't read the word problem yet. If you guys are taking like a timed test, standardized test where you're pressed for time, you see a word problem, oftentimes you can get away without reading the whole problem. Where did I go to figure out what they were asking, by the way? I went to the end of the problem. That's a good test taking strategy. Now look, if you're somebody like me that's kind of OCD, and you might have to fight your impulse to sit and read every word of the problem. That's me. Okay. So like I struggle to think, oh, maybe I'm missing something. Maybe I'm gonna leave something out. But if we sit and read every single word of every single problem, we're gonna run out of what? We're gonna run out of time. Okay. So let's see here. I want to highlight what the info is that they've given me. It says the length of the run is 18 feet. Actually, this is the easier problem. You're welcome, by the way. It's an easier problem than what I thought. So we got 18 is the length. Now, the perimeter of the dog run must be at least 42 feet and no more than 72 feet. All right, so at least 42 and no more than 72, right, means that I need an expression for my perimeter. I didn't spell that right. Am I spelling that right? Meter? I think it's like an I, isn't it? I can't spell or talk to girls. Good grief. All right, perimeter. See, that joke's not as funny anymore now that I'm 36. That joke used to kill when I was in college and I was tutoring kids, and I'd be like, I'm a mathematician. I can't spell or talk to girls. And they'd say, oh, Mr. Morgan, you're so funny. Not anymore. All right, let's see here. So notice what I'm doing. I'm putting some upper bound or a lower bound and an upper bound on the perimeter. Okay? Saying, hey, whatever expression I cook up for the perimeter, actually, you guys will cook it up for me. This is what my compound inequality is going to look like. I put a lower bound and an upper bound on the perimeter. All right. So the perimeter must be at least 42 feet and no more than 72 feet, and the range of values for the width so that we can kind of play around with that. So what I need now from you guys is an expression for the perimeter in terms of W. What's that expression? Work that out on your paper real quick while I take a sip of water, and then raise your hand either virtually or actually in class, and let me know what you think. An expression for the perimeter. Now, feel free to use the drawing to help you. I got to be honest, I'm a little disconcerted that it's taking this long to cook up perimeter. Do we remember what the word perimeter means? Length around the outside. So when I say use the drawing, like what's that bottom side going to be? 18. What's that left side going to be? So what's the perimeter? Come on, be bold. Jack, you got it.
18 times 2 plus X times 2.
What the dump? 18 times 2? Can you not tell me that's 36? Go ahead and tell me it's 36.
36.
Perfect. And then, so we got 2W, 2W plus 36. That's the expression for my perimeter. Okay. Now, here's the next question that I'm going to throw at you guys. Actually, I'll throw it to somebody at home. What word is implied here with this given compound inequality that we just used? Which word? You got a 50-50 shot of guessing. It's and or it's or. Somebody at home? Tiago?
Or.
Try again.
And.
It's an and statement. Now, here's what I mean by this. It's an implied and because the perimeter has to be greater than or equal to 42. It has to be at least 42. What? And that extra stipulation also must be true. That it has to be no more than or less than or equal to 72. Did you catch that I scooted the problem up so that you guys couldn't see the word, but did you notice the word that they used right there? It was sitting there right there in broad daylight telling you, hey, this is a compound inequality using the conjunction and, okay? So both of my green requirements have to be true. And so what we can do with this is we could split it up. Watch how we split it up. You remember? We take the left one and we work it on its own. We take the right one and we work it on its own. So we got 42 less than or equal to 2W plus 36. And we got 2W plus 36 less than or equal to 72. Okay? Go ahead and take you about 30 seconds, solve both of those out. And what we'll get is we'll get another simplified compound inequality for W. Instead of 2W plus 36 being between 42 and 72, we'll have W by itself between two other numbers. And I'm wondering what those two other numbers are. I'm going to walk around and kind of peek at you guys while y'all do this. Nate, you got a question or answer? Good. Well, just hold your horses. Let some of these other guys get it. Nice, very nice. Did I tell you guys what I did this weekend? I took 13 9-year-olds and taught them how to build a fire. We had a camp out. Scouts had a camp out at Chickasaw State Park. And we went and the weather was gorgeous. Oh my goodness. Perfect camping weather. And I mean, we woke up, Teddy and I woke up in our tent Saturday morning at about 6, and it was like 38 degrees outside. It was nice and cold. We went and played 9 holes of golf at Chickasaw State Park, and then came back, went on a nice long hike. Oh, it was so beautiful. 6 divided by 2. And then that night, I taught them how to safely start a fire. And let's see, subtract 36 from 72, divide by 2, we'll get 18. All right, so you guys should have gotten, by the way, while I'm chit-chatting about building fires and whatnot, we should have got that W has to be between 3 and 18, okay? And so notice what I did was I came back and I said, all right, let's put these two together because there's that and between them, right? Now, if I had graphed them out, right? Look at what this would look like. If I had graphed them out individually, here's 3. What kind of mark would I use, Joey, for the W has to be greater than or equal to 3? A closed mark, and I'm going to shade to the right. And then for 18, it's less than or equal to 18. So again, a closed mark. and I'm going to show you to the left. And then just like we said, one of the very first things in class today that we said was that we want, with an and statement, we want for there to be both statements to be true. And so we would conclude, oh, well, here's the overlapped region where I shaded both. And the way that we would describe that region is we would say it's between 18. Okay. Now, have we answered the question? Because we just solved the inequality. Have we answered the question? It says use a compound inequality to find the range of values for the width of the dog run. So Andrew back here building his dog run for, what are we going to call the dog again? Gus. For Gus is, it has to be either 3 or 18 or somewhere in between. Okay, so somewhere between 3 and 18 inclusively. What if I wanted to write that? Just curious if you remember this. What if I wanted to write that using interval notation? Luke, what do you think about interval notation? You remember that? How would we describe this using interval notation?
I don't know.
All right. So the interval, remember, is where you're going to either use parentheses or brackets or a mixture thereof. When do we use, Luke answered just a little simpler question, when do we use brackets as opposed to parentheses?
Closed mark.
Good. So we got 2 closed marks here. So let's use 2 brackets. And then Luke, what's the left side? What's the farthest to the left that I'm going to go in my answers?
3.
And what's the farthest to the right that I'm going to go?
18.
And look at you. You've just done interval notation. Even though you didn't think you could do it, you can do it. You can do it. You can do it if you stick to it. Come on, people. Y'all got to get up to snuff on your kindergarten songs these days. You know what helps me with that? Having a kindergartner. All right. Questions on this example. I know we kind of took our sweet time. Some of you guys, like Nate, I think, and a few of you others had already figured this out earlier on. Any questions at all that you want to ask about it? Okay, it's a word problem, pretty basic word problem. We used our 5 steps. We drew a picture, that helped. And then we did some basic manipulation with some inequalities. We did not have to divide by a negative at all, so we didn't reverse any directions and the like. Okay. Do you have any questions from any activities that we've done recently? Any ACT practice quizzes that you wanted to ask about? Any like in-class assessments? Like I know that I'm at a bit of a disadvantage with you guys because not everybody can access Teams every day, so I'm not able to give like a normal test or quiz to everybody. But I'm trying to sprinkle in opportunities for you guys to practice and use some of these skills. Any questions that you'd like to bring up from some of those assignments? I don't want you feeling like I don't get to answer your questions ever. Speak now or forever hold your peace. Hey, is that okay? Oh, did I leave him? Or good night, America.
Yeah, look,
Is that kind of critter something that y'all could use?
well, we're gonna see if he lives, I don't know, I set up a little tank and a heat lamp,
Oh, cool. He was moving very slowly.
so. Here's the other picture of him.
Oh, dude, that's so awesome. Sharon,
So, I
thank
don't
you.
know.
Awesome. Well, hey, I hope he survives. Tell me what y'all end up naming him.
Okay.
Did I tell you guys I caught a critter this morning? There was over there up against the wall when I was moving my desks around was this little lizard, like he was no more than this big, okay? Just a tiny little lizard. And he had stripes on him, on his back, but he was orange. And you could see into his body, his organs moving around. So I think he's a relatively, like, recently newborn lizard. And so I thought, sweet, I'll capture him and I'll go give him to the biology kids. And then, so yeah, I did. And Miss Record just brought him, she's got him in a terrarium with a heat lamp, making him feel a little bit cozier. Anybody got a lizard at home? Y'all got an iguana or anything? You got one, Joey? What's your iguana's name? Francis the iguana? Wait, Emma, do all of you kids have girlfriends in the 8th grade? What the dump? Goodness gracious, I couldn't even talk to girls in the 8th grade. Y'all are some players. That's what y'all are. Y'all are some play. Well, play on, playa. All right, let's shift gears. We're going to get back into talking about some absolute value. I hadn't helped you guys with some absolute value in a while. We need to discuss. Now, when we discuss, let's do this warm up rather quickly together. This is early morning math. All right, when we discuss absolute value, remember it's the value of a number regardless of its sign. It's how far away from zero that number is. We talked about several different ways. I think I even taught you guys a piecewise definition for it. That if the input or the argument of your absolute value is positive, then the output is whatever that positive number is. If the input is negative, then the output is the opposite of that. So like, for example, the absolute value of -5 would be the opposite of -5, whereas the absolute value of +7 would just be +7. Okay, so in this case, we got the opposite of the absolute value of 7. So what do you guys think that's going to equal? Louder. Yeah. -7, because the absolute value of 7 is 7, and we put the negative on at the end because absolute value acts as a think of an order of operations. What do absolute value symbols act as in that range? Are they P, E, M, D, A, S? They're P. They're grouping symbols, right? So order of operations follows that we would do what's inside the absolute value symbols first. How would we compare on part A? Let's just see if, George, you can do part A? What do you think? Absolute value of -8 is? And the opposite of the absolute value of -8 would be? -8. Very good, because we do the absolute value first, and then we put the negative sign on it. And so what would you say? Greater than, less than, or equal to? Bingo. Perfect. All right. How about, let's see here. I don't know if I've talked to Jake in a while. Jake, what do I do on this one over here? What's the opposite of the absolute value of -12?
-12.
-12 there. So we're going to obviously put a greater than sign. 12 is greater than -12. Yes, no? All right. Just a little review, just a little recap for us, right? Let's see here. Paul, how about this bottom or part C here? What do you think? Camilo? Oof. You guys that are at home, y'all can't interact with these microphones all messed up. Joe Edwards, I'll hit you up. Oh, wait a minute. Paul has made contact.
Hello.
Hello, Paul. Paul, did you hear the question?
Let's see.
Yeah, we're doing part C.
It would be the absolute value of -6 would be greater than -6.
Good, because the absolute value of -6 is +6. Excellent. And then down here at the bottom, negative makes positive, so we got +15. The opposite of absolute value -15 would not cancel each other out. This would be -15. So this one is greater than as well. Ha! Tricked you. All 4 of them were greater than. And you thought there was going to be variety. We'll skip this last one, and we'll move on to our last little bit. We got about 8 minutes in class. And what I wanted to ask you guys was, we've been evaluating absolute value expressions, right? Like what we just did in the warm-up. But have we solved many equations that have absolute value in them? Okay, maybe we've solved a few, but not a lot. Okay, so the question is, what would we do? What kind of method would we employ here to solve an absolute value equation? Look at the 4 steps on the right. Okay, they are almost identical in structure to how we would go about solving a normal equation. Okay, first step, isolate the absolute value part of the expression. Well, we've done that before. That's like getting the x term by itself. I use the expression of peeling back the layers. We talk about Shrek. We talk about onions, right? So you peel back the layers. So look at the steps over here on the left, and let's see if we can employ them in our first little example here, where we're told to solve absolute value of 3x minus 1 and then equals 6. Okay, Joe Edwards, I'll throw it back your way. What do I do to both sides? First step to get that absolute value by itself.
Add 1 to 6.
Perfect. So we got absolute value of 3x minus 5 equals 7. Now I'm going to stop right there. Look at step 2. This is the hard part. This is where students will sometimes screw it up. Okay, so pay attention here. When it says write equivalent equations, what you have to do is split it. Okay, and write 2 different equations. Because absolute value of, let me make sure y'all got your steps still where you can see. Absolute value of something equals 7 means that that's something, whatever it is, in this case 3x minus 5, it lives 7 spots away from 0 on the number line. So look at what I can do visually. You guys will see this all year long, how I like to visualize a problem. Here's 0, here's 7, here's -7. Okay, 3x minus 5 is 7 spots away from 0. So 3x minus 5 could live over here, or it could live over here. In other words, it is equal to -7 or +7. And those are going to be in step 2, my equivalent equations. 3x minus 5 is equal to -7, or 3x minus 5 is equal to +7. Notice I use the word or. Okay? Kozlowski, do you play a sport?
Yes, sir.
Okay, do tell. What sport?
Cross country.
Excellent. I got mad props for you cross country guys. Hey, speaking of cross country, my little mountain bike team, got a mountain bike team here at Christian Brothers. There's about 18 boys on it, and we were out in Lakeland the other day, and they had the best practice of their lives because at Lakeland it just so happened that there was the girls cross country team from Arlington that was there. A bunch of cute little high school girls wearing skimpy short shorts and sports bras. And so my guys saw these little high school girls running through the woods, and they're like, ooh, yeah, let's go. And so they rode hard, and they did all these tricks and jumps, and they were super excited. And those girls were out there just trying to get a workout in. Why are y'all looking over in that area? Will, what, you got a girlfriend or something? Goodness gracious me. What, Jack?
If anyone in the back that like had a question or go on.
Oh, so if you got a young lady, you better keep it to yourself. Is that the rule of thumb? Okay. Otherwise, people are going to dog you for it, huh? And of course, the girls will hear about it then, and you'll be all embarrassed and whatnot. Oh my. All right. Well, anyway, Colin, back to you, dude. You run cross country, right? So, like, let's say I don't know a good 5K time for a middle schooler. Colin, what would a good 5K PR be?
For me,
Yeah.
20 minutes.
All right, sweet. Okay, so like, let's say Colin says my personal record PR is 20 minutes and is 22 minutes. That doesn't make sense, does it? You can't have something equal to different things at the same time. All right. Y'all know who Mike Trout is, right? Highest paid professional baseball player. Like, he's just raking in millions of dollars every year. We can't say that Mike Trout has 14 home runs and 17 home runs at the exact same time. It doesn't work that way. So I can't say that 3x minus 5 equals -7 and +7 at the same time. Instead, what must I use? I must use an or statement, okay? So down here in step 2, be mindful of the word that you use. I'm going to put an or right here to remind you guys of that fact. That when you're writing the equivalent equations, you must use an or, because you can't have your expression equaling two things that are different at the exact same time. Now, from here, look at step 3. It just says solve each equation, check each solution, and this is where we just kind of mosey on through the rest of the problem pretty easily, right? In fact, I bet some of y'all have already done that. Add 5, we get -2. Divide by 3, we get -2/3. So that's one solution. Here we add 5, we get 12. Divide by 3, we get 4. So there's my other solution. Okay, so -2/3, or, actually I don't write or there, sorry. I'm speaking and writing at the same time. Y'all ever do that? You accidentally write what you're speaking when you shouldn't? All right. So those are our solutions to this equation. Is it okay that I've got an equation that has 2 solutions? Abso-freaking-lutely. Okay? What does it mean to solve an equation? To find any and all of the numbers. That when you plug them in for the variable or variables, it makes a true statement. So if I plugged in both of those numbers at the original up there in black, I would get a true statement. That's how we go through solve an absolute value equation. Okay? Tomorrow, what we're going to do is we're going to jump in and we're going to solve some absolute value inequalities. And that's where the poop is going to hit the fan, so to speak, okay? That's going to be where it gets a little bit more challenging. So we can't be thinking of all our little girlfriends, and we can't be thinking about all our, distractions. We got to bring our A game tomorrow. You guys will be doing it digitally. You guys that are here in person today, you guys that are at home today, you will be bringing your A game here in person, Lord willing. And tomorrow I might have to let you go a little bit early. So please tell your parents we're giving the ACT up here tomorrow. So I'm going to have class, but I might let you go a little bit earlier than 10 till. So you guys that are here in person, make sure mom, dad, whoever is aware of that. Tiago, you got a question? I didn't say that gum leave yet. Sit down and be quiet. Tiago, you have a question.
Do we come on Thursday and Friday?
Heck no. CBHS is closed Thursday and Friday for fall break. And I'll be in lovely Hot Springs, Arkansas, jumping down some mountain bike trails with the guys. So tomorrow will be our last day of class until the following Tuesday. Got it? You guys got it? All right. Live Jesus in our hearts. Hit the door. Thank you so much. Y'all have a great day. Paul, what's your question, buddy?
Do you know I'm not going to be here tomorrow?
I think I got an email to that effect. You can play catch up. Just watch the video.
All right.
Thanks, buddy. Take care.
Thank you.